Well, thank you, Adriana, for inviting me to be here. I've never been to Montreal, so I'm very excited to be here, and it's been wonderful listening to these other talks. Mine is going to be a little bit different, as you can see just from the beginning slide here. We haven't seen any rats so far today. This is what I work with. I look at animal models of addiction. And with regard to sex differences, it allows us to address the question of, are sex differences that we see in humans, do they have a biological basis? And if so, what is that basis? So the main take-home message that I want to relay to you today is that although men are more likely than women to use and abuse drugs, women may actually be more vulnerable on many different phases of the addiction process. So that's something to consider. So I'm going to talk about both human studies and animal studies to see what's the difference in humans. Is there a parallel difference in animals? And if there is, that suggests a biological difference. So drug addiction, and mainly for illicit drugs, is a process that's characterized by a shift from casual recreational use to compulsive and binge patterns of use. So initially people are using the drug for its reinforcing effects or the reward properties that it has, but after a while that may be less of the case. They may feel compelled to use the drug, or they may have craving. Men and women have been compared at each of these different phases. So we do have a lot of data behaviorally in both humans and animals now. Probably the biggest difference between men and women is revealed through epidemiological data. So these are rates of use, abuse, and dependence for illicit drugs, including cocaine, alcohol, and cigarettes. As you can see here, men are more likely than women to use these drugs, abuse these drugs, and be dependent on these drugs. However, when you look among adolescents, and this was mentioned in an earlier talk, Mary's talk earlier today, drug use is increasing, particularly in females. And so now when you look at current use, abuse, and dependence, females are actually more likely than males to use illicit drugs like cocaine, and they're more likely to abuse illicit drugs and alcohol, and equally likely to be dependent. There is also data showing that female adolescents will progress to addiction faster than adolescent boys. So sex differences have also been noted for the different phases of the addiction process in adults. So even though more men are using drugs, you see these vulnerabilities in women. Women appear to have an accelerated course to addiction, so not just in adolescence. Once women begin using drugs, they seem to enter treatment programs sooner, and they develop problems associated or characteristics of dependence at a faster rate than do men. They also report shorter abstinence periods, and different cues seem to trigger drug craving and relapse in women as compared to men. So I'm going to ask 3 questions in my talk and try to address the human and the animal studies to look at the underlying neurobiology, the underlying biological basis. So do women and men differ in the initiation of drug use? Based on the historical data, you would expect that males would be more vulnerable. This is not the case. Does the progression to addiction differ between men and women? And do men and women differ in treatment outcome? And this is something that has not been explored very much in the United States and apparently also in Canada. NIH requires that women are included in treatment studies, but they do not require the number of women to be at a level where you can actually assess for sex differences or the effects of a compound in women. And in animal studies, of course, it's all done in males until very recently. Treatment studies still are not done. So I have some preliminary data that I'll share on that for a non-pharmacological treatment. And as I said, I'm going to explore the biological basis by comparing human and animal studies. So are women less vulnerable than men to addiction? As I said, they've had historically lower rates, but sex differences disappear or reverse among adolescents. So what do the animal models show us? Well, this is the basic setup for looking at, one of the basic ways to assess vulnerability to drug reward is to use a drug self-administration paradigm. And this is what we use in my lab. You have an animal, you have implanted a catheter. Well, if it's an IV drug, you implant a catheter, it exits right at the heart, and then what they can do is they can lever press to receive an infusion of the drug that comes down through this tubing. So it's an immediate IV infusion. And you would use IV for a drug like cocaine that has a rapid onset that is used either smoked or IV in humans or snorted. When we're modeling alcohol, we have the animal self-administer it orally. But for cocaine, this is what we use. And we use low doses of the drug to ask the question, which animals can detect this low dose of the drug? Some animals are going to be able to detect its rewarding effects and some are not. So under those low dose conditions, that's where you are looking for individual differences. And when you compare males and females on acquisition of drug self-administration under low dose conditions, what you find is that females exceed males on a variety of different drugs. And these have been replicated many times. So cocaine, I actually have some data on cocaine here showing that females are more sensitive to the rewarding effects. So let me just orient you here. This is the mean percent of the group to meet the acquisition criteria. So it's basically when they start lever pressing for the drug. And it's across a 30-day period. So females are way up here. About 70% of the group meets the acquisition criteria within the 30-day period, and they do so at a pretty fast rate. About 30% acquire right away, as comparison to the males, where only about 30% of the males acquired under these conditions, and it wasn't until day 15 that the first one did acquire. So you're really seeing a nice, robust difference here. For heroin self-administration, females have a higher rate, but by the end of the testing period, both males and females had acquired. So females are showing a greater enhanced sensitivity to the rewarding effects of drugs of abuse. So what could this be due to? Well, there's certainly evidence for some drugs of pharmacokinetic differences. So, for example, when males and females have a similar dose of ethanol, of alcohol, females will have higher levels of alcohol in their blood and brain. Same is true for amphetamine. But other drugs like cocaine, they'll have the same number or the same amount of amphetamine in their brain as compared to males. So it doesn't account for the differences that we see. But hormonal influences, there's a lot of data showing that hormonal influences, hormones influence vulnerability to addiction. And I have some data to show you on that. So for example, in women, the subjective effects of cocaine and other psychostimulants vary with menstrual cycle phase. So they seem to be greatest when estradiol levels are high and relatively unopposed by progesterone. So this is different than what we've heard from the other talks, where too much estrogen here is going to cause some problems. It does appear to enhance drug reward. And in rat studies, what we see is that drug self-administration behavior, particularly how much they're willing to work to get the drug, how motivated they are for it, that's estrocycle dependent, and it also varies with the levels of estrogen and progesterone. So this nicely shows, I think, the effects that estrogen can have on vulnerability to cocaine reward. And this has also been shown for other drugs as well. So this is laid out as the other figures I showed across a 30-day time period. Now here you've got groups with estrogen and groups without. So this is a sham surgery group. They still have their ovaries, and they were treated with vehicle. So intact females or animals that had their ovaries removed but had estradiol replacement. These animals, like the intact females I showed you earlier, acquire rapidly, and a greater percentage of them acquire as compared to the no estrogen group that looks like the males. So you've got a sham group that received the anti-estrogen tamoxifen and an ovariectomized group that received vehicle. So when I saw those data, this was a while ago now, I was very excited, and I thought, well, estrogen is the answer. This is why females are more vulnerable. But it does not appear to be the case that it's the whole answer. Progesterone is very important. It seems that it's the ratio of estradiol to progesterone that really predicts the rewarding effects of drugs. And actually, progesterone can counter the effects of estradiol. And they're looking at progesterone as a potential treatment for drug abuse, for nicotine, for cocaine, in both men and women. So that's the data look good, too. Another way that we've looked at hormones is by looking at hormone transition phases. And there isn't a lot of work that's done in adolescents and animals because it's a very narrow window of time that you have to look. But it's a great place to start when you're looking for hormone relationships. It's definitely a hormone transition phase. There is an apparent vulnerability to initiate use. If you smoke in adulthood, more than likely, like 90% chance that you started smoking while you were a teenager. And adolescents seem to progress more rapidly to dependence after initial use than adults and show higher rates of dependence. They're also harder to treat the earlier you began using drugs. So we do have a rodent model of adolescence, but as I said, it's really short. You have days to study this. So not many people have done it. That's why addiction studies have looked at adults. But we start before the surge in gonadal hormones, which occurs early on postnatal day 28. And we're monitoring behavior throughout these important points in adolescence that we model in these animals. And by adult, they're considered adult by day 60.